Hello everyone, I'm Chuhan Wu from the Department of Electronic Engineering, Tsinghua University. I'm very glad to present our work named SentiRec, Sentiment Diversity Aware News Recommendation to you. In recent years, online news websites such as Google News, Amazon News, and Total have attracted massive users for online news reading. Unfortunately, thousands of news are generated every day, and this news will overwhelm our users. Thus, personalized news recommendation techniques are very important for these platforms to alleviate information overload of their users and improve their reading experience. There are many existing works for personalized news recommendation, and for most of them, mainly rank candidate news based on their relevance to the user interest inferred from their news clicks. For example, in the decade method, the click score are computed by the concatenation of the candidate news embedding and the user embedding via a deep neural network. And in the NPA method, the click score is computed by the inner product between the news embedding and the user embedding. Since existing methods usually match the user interest and the content of the candidate news, we observe that the content or the sentiment of news recommended by existing methods are usually very similar to those that are previously browsed by a user. This figure shows the two candidate news recommended to the two users on the Amazon News. We can infer that the two candidate news that are all about San Francisco are recommended to the first user due to her interest in the San Francisco city, and the two candidate news are recommended to the second user due to the interest in the negative news. Means that the user may intensively click several news that have negative sentiment. However, it poses significant challenge to existing methods that we may intensively recommend news with the same sentiment orientation to some users, and this is inappropriate. We need sentiment diversity in news recommendation. Motivated by the previous observation, we propose SentiRec, which is a sentiment diversity-aware neural news recommendation method. Our approach contains 5 core parts. The first one is a sentiment-aware news encoder. In the sentiment-aware news encoder, it mainly aims to learn the sentiment-aware news embedding from the title of the news. As shown in the right figure, each word in the news title will be converted into its low-dimensional semantic embedding via a word embedding layer, and then we use a transformer layer to learn the contextual news embedding based on the interactions between words. Then we use a sentiment predictor to predict the sentiment score based on the contextual news embedding. Then we propose an auxiliary sentiment prediction task to predict the sentiment scores of news based on their embeddings. By optimizing the loss function in this task, the sentiment information can be encoded into the news embedding, and hereby it can be sentiment aware. Then the second module is the sentiment analyzer. In this module, we do not restrict the implementation of this module. It can be neural networks or traditional methods. And this model mainly aim to compute the real-valued sentiment scores for each news in this module. And it also used to obtain the label for the sentiment prediction task. And the third one is a user encoder. This module mainly aims to compute the user interest embedding based on the embeddings of the previously browser news. And the fourth one is a click predictor. This one mainly aims to match the candidate news embedding and the user interest embedding to compute the final click score. And the final module is a sentiment monitor. This one mainly aims to regularize our model to provide sentiment diverse user recommendation results. For the sentiment monitor, it receives two scores as the input. The first one is the sentiment score of the candidate news, and the second one is the average sentiment scores of all the browser news. It indicates the average preference of the user on the sentiment that is inferred from the overall sentiment orientation of browser news. And in the sentiment monitor, we compute a sentiment diversity score based on this function, and we design a sentiment diversity loss function to regularize our model. And for the main recommendation task, we use the loss function shown in this formula. For each positive sample that is clicked by the user, we randomly sample several non-clicked samples and jointly predict the scores of these samples. And the final loss function is the likelihood of the clicked sample, that is the positive sample. And our model is jointly trained in the three tasks, and the final loss function is a weighted summation of the loss function for each task, which are weighted by the hyperparameter lambda and mu. Let's turn to the experiments part. The dataset used in our experiments contain 10,000 of users and their logs on Amazon News, and the statistics of this dataset is shown in this table. For the sentiment analyzer, we choose the Vader algorithm, which is the famous lexicon-based sentiment analysis method, which can compute the real-valued sentiment scores from -1 to 1. And it shows that for news with negative sentiment, it can usually compute a negative score, and for news with a positive sentiment, it compute a higher positive score. And based on this sentiment analyzer, we can compute the sentiment scores of all news, and we obtain the several interesting results. We can see that the news usually have a neutral sentiment in average, but for users, we find that it is interesting that the average sentiment orientation of the browser news for users are usually a little negative. And from the right figure, we can see that for the news with more negative sentiment, the CTR is higher. It is very interesting because if we mainly aim to optimize the CTR metric, we may mainly tend to recommend more negative news, which is inappropriate. So we need to explore the sentiment diversity, not to only optimize our CTR metric. When we introduce the metrics used in our experiments for the news recommendation performance, we use the AUC, MIR, NDCG at 5, and NDCG at 10 scores. However, for sentiment diversity, there is no off-the-shelf metric to evaluate the performance, so we propose three different methods to evaluate the sentiment diversity, and our methods are based on the ideas of MIR and hit ratio at 5 and at 10. We compare the performance of our method with many baseline methods in terms of recommendation performance and the sentiment diversity. And in the left table, higher results means better recommendation performance, and in the right table, lower scores indicate better diversity. We can see that compared with the baseline methods, our sentiment diversity aware news recommendation method can achieve better recommendation performance and better sentiment diversity. And by comparing the variant of our method that only recommend news with the same sentiment orientation with browser news. We can see that although the recommendation performance is slightly better, the sentiment diversity is much worse. So we need to provide sentiment diverse recommendation results. The result shows that our method can greatly improve the sentiment diversity without hurting the model performance. Then we conduct several ablation studies to explore the influence of the sentiment prediction and the diversity reorganization tasks. We compare the performance of our SentiRec method with its several variants with or without the two tasks. And from the results, we can see that the sentiment prediction task is very useful. It can not only improve the recommendation accuracy and the sentiment diversity. In addition, the diversity organization task can also greatly improve the sentiment diversity. However, it will bring a little decline in the AUC of the recommendation performance, but the decline is also acceptable. So by combining two methods, our method can also achieve a very good recommendation performance and a very good recommendation sentiment diversity. We also explore the influence of the different hyperparameters, and the left figure shows the influence of the hyperparameter lambda. By changing the values of lambda, we plot the results of the sentiment diversity and recommendation AUC. We can see that when the values of lambda increase, the sentiment diversity improves, and also the recommendation performance also improves. However, when lambda goes too large, the sentiment diversity cannot be significantly improved, but the recommendation performance starts to decline. So according to the results, we choose lambda to 1.4. And from the right figure, we set lambda to 1.4 and change the values of mu. Since the scale of the sentiment localization task is usually relatively small, so the scale of mu is larger. We can see that when mu goes larger, the sentiment diversity can also be significantly improved. However, when the values of mu goes too large, the recommendation performance declines significantly. Thus, according to the results, we choose the value of mu to 10 to keep a good balance between sentiment diversity and recommendation performance. Finally, we conduct several case studies to visually explore the effectiveness of our method. We show the browser news of a user and the top-ranked candidate news provided by different methods, that is, NRMS and SentiRec. We can see that the overall sentiment orientation of the browser news is very negative. However, the NRMS method continues to recommend negative news to this user. For example, the first news. Maybe recommend too much negative news is not appropriate in this situation. Fortunately, our SentiRec method can recommend news with positive sentiment to this user, and this user may receive diverse sentiment and may not be influenced by the bias of the news recommender system. Finally, we conclude our paper and discuss the potential future work. In this paper, we propose a sentiment diversity-aware neural news recommendation method that contains a sentiment-aware news encoder to a sentiment-aware news embedding and a sentiment diversity regularization method to regularize the model to provide diverse news click scores. And the experimental results show that our model can enhance sentiment diversity without hurting recommendation performance. And in our future, we plan to explore the entity-level sentiment diversity as well as extending our model to emotion diversity-aware neural news recommendation. That's all. Thank you for your attention.